Let's do a basic look at random number generation in Excel, and while we're going through that, you should also learn how to insert functions, how to recalculate values in a spreadsheet, or how to force that recalculation, how to copy lots of data, and how to create a histogram using some of the basic functions in Excel. So suppose you want a random number, and there's all sorts of distributions you can think of, maybe from your statistics classes. If you remember, there's normal distribution and there's uniform distribution, Gaussian, you've heard that term before, same as normal, exponential. The most basic one and the easiest one to get to in Excel is a uniform distribution. And what that means is it's a function that returns a uniform random number between 0 and 1, meaning that the probability of getting any number between 0 and 1 is the same. So the chance of getting a 0.5 is exactly the same as the chance of getting a 0.762342. And the way you enter that function in Excel, assuming you have some idea of what it is you type equals rand, and do it right, and you have to close and open and close the parentheses even though there's no arguments. Otherwise, Excel does not recognize it as a function. Hit enter, and you there have a uniform random number. Now you can force Excel to generate a new random number by either pressing the F9 key. Notice I'm pressing it now and it keeps changing. Another way to do that is to go to the Formulas tab. This is the newer version of Excel, and you can do Recalculate All repeatedly, and notice it keeps changing the numbers. Now, so we're looking at back up. So if you don't know what the function is, notice there are some tools here on this function bar that allow you to search for functions. You can use the formula builder, which has a search and will allow you to start typing the word random, for example, and then you will see that there are functions called rand and rand between. And then if you click on the function you want to do, the formula builder will let you build it. As it says here, to begin, double-click on the function, double-click on rand, and it says there's no arguments. Notice it built it for us in the cell now, and if we simply hit return, we now have two places where there's random numbers. There's also a function reference, which if we click, takes a minute to come up. Yep, there it is. And now we can look up functions. This is a little more difficult because you know what category it's in. So I happen to notice that rand was under math. So we can now look at the random function, and it has a more detailed explanation of how it works. So another thing you can do, of course, is just jump on your web and go Google for it. You would Google a search term, something like random numbers Excel, and it would, well, let's just try it. If I go here and I Google random numbers Excel, random numbers Excel, we get a whole list of how to generate random numbers in Excel worksheets, and it just goes on and on and on. Like anything else that you find on the web, some of these are probably really good, some of these are probably really poor, but it is another way to find out how to do things in Excel. Okay, now think about random numbers and the distributions that they're supposed to follow. So let's suppose we wanted to actually verify that this is a uniform distribution. How might we do that? So this is a place where you can pause and think about that for a second, but I'm just going to keep on talking. So one way to do that would be to, as we've done before, just keep pushing this recalculate button and keeping a list of the numbers, see what goes on. I'm going to ignore that phone call. That would be kind of tedious. Another way we could do this is simply copy a lot of, or fill a lot of cells with the random number function. The easiest way to do that in Excel is to actually select a large number of cells. So let's do, statistics is all about large numbers. Let's do some, okay, my spreadsheet seems to be stopping at 680. So let's select the cells from 1 to 680. You do that by selecting one first, scrolling down to where you want to go, then holding the Shift key while you click again on the cell you want to end at. So I clicked on 680. Now I type equals rand. Notice it's putting it in the first cell. And then instead of just hitting enter, I press Control Enter. And now what it's done is filled every one of those cells with the random number. Cool. So I've got 680 random numbers here. Okay. Now, one way that I can convince myself that these are uniformly distributed is to think about what the average of the distribution would be. So if we've got random numbers uniformly distributed between 0 and 1, the average should be what? Should be 0.5. So in this box, I'll just pick a box at random, no pun intended. I'll use the average function. So equals average. And the way we work with average is we give it a list of numbers. So I want to go from A1 to A680. And lo and behold, the average is about 0.5. Now, we can then repeatedly recalculate and watch how that average changes. Notice that it's always hovering somewhere around 0.5. Okay, so what else might we do to verify that this is actually a uniform distribution? So remember what I said before, which is that a uniform distribution is one in which you've got equal probability of the numbers occurring, and our distribution is between 0 and 1. Well, that would mean that if we had some way to look at the numbers along that distribution in a more compact way, we might be able to see if that distribution is actually even. So if I think about that for a minute, maybe if I looked at the numbers between 0 and 1 in, say, increments of 0.1 and see how many of the numbers fit into each of those bins, I would be able to tell whether the distribution appears to be normal. So suppose we want to create a list of bins in which to put these numbers between 0 and 1 in increments of 0.1. One easy way to do that in Excel is to type the beginning of the series you want to create, then type the first one in the increment. So I want to go from 0 to 1 in increments of 0.1. Now I could continue typing 0.2, 0.3, 0.4, and then that wouldn't be so bad going to 1, but if you wanted to go a long way, it would take a long time. But what we can do instead is highlight those two values, right? And then grab this little blue dot and drag it down. And it auto increments in whatever increment you started with. Since I started with a 0.1 increment, that's what it does. Okay, so now we have what's called our bins that we can ask the computer somehow to tell us how many numbers are between 0.1 and 0, between 0.2 and 0.1, between 0.3 and 0.2, and so forth. And this is one of those things where you either have to ask someone or sort of figure it out by, well, just searching and searching. Asking someone is easier, someone who knows Excel. There happens to be a function called frequency that allows you to do exactly what we want to do. And this is a weird function because it uses what's called arrays in Excel. So let me tell you how you have to make this function work. First, we're going to want a value for each one of these bins. So you highlight all of those cells. So this is kind of like we did before when we entered the random number variable. Then we have to start typing. So we start typing equals frequency. And I'm going to stop there. Whoops, that's not good. Equals frequency. Equals frequency, select it, and now it asks what you want. So the data array is the list of numbers that you wanted to put into the bins. So that's our first column. So we put in A1 to A680 into there, and then it wants a comma, and then it wants the bins array. So that's the array that we just created from 0 to 1, and because it's right here, I can just highlight it like that and enter it there. Now, this is where things get a little bit weird. If you just hit enter, it doesn't do the right thing because this is called an array function. What you have to press simultaneously here to make this work correctly is Control, Shift, and Enter. all at the same time. And apparently I messed something up. Let's try that again. This actually took me about a half hour to figure out. So I've got the cells selected, equals frequency. Oh, I remember when I did this wrong. It was when I went back and entered it again because I spelled it wrong the first time. A1 to A680. And let me grab my bins. I got that. And now let me hit Control Shift Enter. Now see what it did. It filled all of the values all the way down in the cells I selected. Now, the way you read this result is that there are no numbers less than 0, which makes sense in a uniform distribution. There are 59 numbers between 0.1 and 0. There are 69 between 0.2 and 0.1, 74 between 0.3 and 0.2, and so forth. If we add these up, they ought to come out to 680 because that's how many numbers we have. You should get into the habit of doing this kind of sanity check as you do your work. So we indeed do have 680 numbers. Notice every time I do something new, it recalculates. So one thing we could do is just hit recalculate a bunch of times and eyeball this and see that the numbers are approximately equal, which is what we'd expect for a uniform distribution, about the same number of numbers in each category. Okay. Another thing we could do instead that's maybe a little bit more elegant, and I'm going to get rid of this column because I want some room. Edit, delete column. So here's our average over here. Let me label that. So notice our average as we recalculate stays around 0.5. Notice that our numbers are about the same. They're all on the order of, well, whatever, well, 68 roughly per bin. Now, suppose we want to create a graph. We can highlight, well, we don't really need the 0, so let's just highlight from 0.1 to 1, and then go over to the Charts tab and create a column graph. And a clustered column is fine, and it gives us a basic graph. Now this graph is kind of messy. I don't know why Excel has some of the defaults that it does, but it does. So what we need to do is go in and clean this up. Notice that it's actually charted the series 1, which is the column D, 0, 0.1, 0.2, 0.3. We certainly don't want it to do that, so we go up to Chart and Source Data, and we simply remove the Series 1 tab. Now notice that our x-axis doesn't really reflect the numbers in the D column. It simply counts the entries from 1 to 10. We can simply go over here to the category x-axis label and then highlight this area here and hit OK. And notice that we now have a graph that reflects what we want it to reflect. Let me get rid of this column as well, so I can move this to the side and we can see the numbers. Well, I'm going to get rid of this because we really don't need it. And I'm going to shrink this a little so that we can see the numbers in the graph at the same time. And notice, as you might expect for a uniform distribution, the levels of the bar are approximately equal. And we can repeatedly recalculate this. I'm going to push F9. And notice, it changes, it varies, but more or less, all the bars are somewhere around 68 plus minus. And if you did this with 10,000 numbers, again, statistics, law of large numbers, you would have a set of bars that were much more evenly leveled. Okay. And that's it.